Hi people, today we're going to be going over integration. So we know the normal rules of integration from GCSE and AS, that if you integrate something to the power of n, as shown in the example, you're going to increase the power and then you divide by the power and you have your plus c as your constant. Now this is C4 integration. What we're going to do is basically show you all of the trig identities that you need to know, and you need to just memorize, to be honest. So integral e to the x, 1 over x, cos, sine, sec, cosec, cot, sec, tan. The main thing about integration is you need to remember that it's the opposite effect of differentiation, so you're working backwards. So for example, sine differentiates to cos, and cos therefore integrates back to sine. And obviously plus c. Now you also need to know when you integrate, not necessarily just x, but maybe just a different angle. So here we have ax plus b, and what we do is we differentiate the bracket and then we do 1 over whatever's inside the bracket. So here we have ax plus b. When we differentiate that, we just get left with an a, because x is power of 1, then get cancelled, so we just get an a, and then we just pull out the a and do a 1 over. The reason why we do that actually is because if you think about it, when we work backwards, that a will cancel out again when we differentiate, so it'll be a over a, which is just 1. So just memorize again all the trig identities listed below, and we also need to know the integral of tan, sec, cot and cosec, which is slightly different where you have ln involved, but again it's just memory work, and you can actually work backwards from that by doing, for example, tan is sine of cos, etc. Now we also in C4 integration need to remember our trig identities. So sine squared plus cos squared is 1, and remember we can actually derive different equations from that one equation. If we divide everything by cos, we get tan squared x plus 1 equals sec squared x, and if we divide everything by sine squared x in that equation, we get 1 plus cot squared x is cosec squared x. And then obviously cot is cos over sine, tan is sine over cos, and then also we've got our final identities, which is sec is 1 over cos, cosec is 1 over sine, and cot is 1 over tan. Now let's get into some examples. So example 1, we've got integral of 2 cos x plus 3 over x minus root x. So here what we're going to do is, we know that the integral of cos, if you go back to your sheet, is sine, so we get 2 sine x plus 3 ln x, because it's essentially 3 times 1 over x, and when we integrate 1 over x as seen on the sheet before, that gives us ln x, and then we just have the 3 in front, and then we integrate x square rooted as normal, and obviously add our plus c. Now in the next example we have integral of cos x over sine squared x minus 2 e to the x. So sometimes we actually have to simplify it in order to integrate it. So here we have cos of sine squared x. We can write this as 1 over sine x times by cos over sine, and then cos over sine is cot, so then we've got cot times 1 over sine, and that's cot cosec, and we know the integral of cot cosec is of course minus cosec squared x, and then we integrate 2 e to the x. E to the x always stays the same whether it's differentiated or integrated, it's just e to the x. So here we just have 2 e to the x plus c. Now when there's an angle, as we said earlier, ax plus b, slightly different. You differentiate the bracket, remember, and you pull out whatever the differential is and you do 1 over that. So here we've got cos of 2x plus 3, that will integrate to sine 2x plus 3, but something must be in front. Now if we differentiate 2x plus 3, we get a 2, so we're just going to put 1 over 2 outside the bracket, hence we get half sine 2x plus 3 plus c. Now in the next example we have sec squared 3x. Now when we have slightly different angle. Remember, we keep the angle the same after we've changed the identity. So what I mean by that is that when we actually integrate this, we get tan 3x, not tan x. So we always keep the angle the same, but when we differentiate 3x, we get 3, so we have to pull out a 3 and then do 1 over, so hence we get a third tan 3x plus c. Now, in the next example 5, we have 2x plus 3 to the power of 4. Now, when we have a bracket, the way we integrate is that we increase the power, divide by the power, obviously, and then we have to differentiate the inner bracket and then do 1 over that. Hence, we get a half times by a fifth, 2x plus 3 all to the power of 5 plus c, so we get 1 over 10 2x plus 3 to the power of 5 plus c. Now in the next example we have 1 over 3x plus 2. Now we recognize this trend by essentially when we have 1 over something, we sort of recognize this trend that it has to do something with ln, because remember, when we differentiate ln we always get 1 over x. So here we've got 1 over 3x plus 2, so integral is going to be ln 3x plus 2. Now what we do is that if we differentiate this, we have to work backwards here. We know that we're going to get a 1 over 3, so we get 3, so we have to do 1 over 3 to cancel out that extra 3. So here we get a third ln of 3x plus 2 plus c. That's it. Hopefully you've learned something from that, and look at the next video for using trig identities. Please like, subscribe, and peace.